Okay, so what we're going to talk about today is we are going to talk about circles. We're going to talk about how to find the center of a circle, how to find the radius of a circle, how to graph a circle when we have the center and radius, how to take the equation of a circle and put it into center radius form. So we're actually going to do quite a bit today. Okay? A lot of what we're doing is review from geometry. So the center of a circle, or center radius equation of a circle, you guys should know. You should know distance formula, which is going to be used quite a bit with circles. And this should all be from last year. Okay, so hopefully you remember. All right, next page. So on page 1.3, I'm going to give you a circle with a center at point O and the equation of the circle. What I want you to do is I want you to move point O, or that center of the circle, and determine a connection between the coordinates of the center of the circle and the equation of the circle. Okay, so again, what you're going to do is you're going to take this point right here, you're going to grab it, and you're going to move it. You're going to watch for the connection for this equation here, okay, and see how it changes. So go ahead and play around for a minute, and then we'll talk. Okay, so when I take the center of the circle and I move it, what's changing? Yeah, these values in my equation are changing, right? So what do you notice about the signs? Good. The signs are opposite of what they are, right? Yes. Okay, very good. So these two numbers here, okay? Good. That's H and K, and that represents what? The center of the circle. Now, what are we doing with the signs? We're flipping them. We're changing them. And what does this represent? Okay, we're going to find out in just a moment. We're going to make sure that we're right. Okay, so good. So those two values do represent the center of the circle, and we do change their sign from positive to negative. Okay, and the reason being is we have a general formula for a circle. Who remembers that general formula for center radius? Good. Good. Y minus K. Great. So that's your center radius form for a circle. That was from geometry last year. So if you don't know it, it better be written down in your notebooks and starred because you need to have it memorized. Okay? So this is center radius form for a circle, where HK is the center and R is the radius. Okay? So you need to make sure that you know that. So when you get the center, you pop it in, and what you're going to see happen is those signs are going to switch, okay, because of the minus, because of this here, changes those values. Okay, are we ready? How about now? Okay. All right, so what relationship do you notice between the coordinates of the center of the circle and the equation of the circle? In your own words, write down the correlation between the center of the circle and the coordinates in the equation. Okay. So the relationship we notice between the coordinates of the center of the circle and the equation of the circle, they're the values of HK. Their signs switch when we plug it into the equation, right? Are we good? Okay, so on 1.6, you're going to take point A and you're going to move it around. You're going to determine the connection between the distance of the radius and the equation of the circle, and then we're going to answer the following questions. All right, so you're taking point A, and you're going to take point A and you're going to move it around, and you're going to determine the connection between what's happening to the circle and to the equation. So take a minute to play. Okay, so when I take A and I move it around, what's changing in the circle? Yeah, the radius is changing, right? So notice in the equation, the value that the equation's equal to is also changing. Is it always pretty numbers? No, it's not always going to be pretty numbers, okay? So you have to get used to them being not pretty. You're not always going to be able to count out what the radius is. So that brings us to another issue. If I can't count out what the radius is, how do I figure out what the radius is? Well, let's say I have a point, the center, and I have a point on, good, I want to find the distance, right? So I use what formula? Distance formula. What's the distance formula? Square root Wow, this is awesome. X2 minus x1 squared. Good, so there's your distance formula, okay? Yes, you may. That's for the circumference of a circle. Pi r squared is for the area, okay? All right, so if you're given a point on the circle and you're given the center of the circle and you need to find the radius, we use distance formula. This is another one of those things that you should know from last year. Okay, yes, some of you did, some of you were a little less sure of yourselves. Okay, so you do need to be able to use that, and it's going to get used quite often. Okay, so we're not always going to be able to count out the radius, so you guys have to know distance formula. Got it? Do we remember it now? Yeah, okay, good. Excellent, excellent. Okay, so on the next page, what is the relationship that exists between the distance of the radius and the equation of the circle? What's changing in my equation? Yeah, the r, what the equation is equal to is changing. Okay, so as the radius of the circle gets bigger, the value that the equation is equal to also gets bigger. Okay. In your own words, or however you're going to make the connection between the radius and where it is in the equation. Got it? Okay, so are you guys ready? Say yes. Yes. Okay, so what is the equation of the circle centered at 1, -2 with a radius of 5? Now, don't say it out loud. I'm going to send you a quick poll. You're going to answer it. How do we send quick polls back? Doc enter, okay? You haven't gotten it yet. I haven't sent it yet. Okay, but I just sent it. All right, so go ahead, answer the quick poll, and we'll go over it in just a second. All right, so let's see how everybody did. Let's stop the poll. All right, 10 out of 11, you are correct. It is choice 4. If the center is 1, -2, remember we flipped those signs, -1, +2. Radius is 5. We have to square it, 25. Okay, nice job. Okay, so let's try another one. Let's send this out to you. What are the coordinates of the center of the circle with equation x minus 4 quantity squared plus y minus 5 quantity squared equals 36. So go ahead, send it back to me. We'll go over it in a second. Okay, so let's see how we did. Oh, all right, everybody got it right. So the center is 4, 5. Again, we switched those signs, right? Great job. All right, let's try another one. Okay, what is the radius of the circle? No. We'll talk about it in a moment. All right, so go ahead. Let's go. This should be quick. Fast and snappy, guys. I have 12 out of 12 submitted. Awesome job. And everybody got it right. We understand center radius. No punching. It's not nice. Okay? Okay, so here's where we get a little bit more difficult. All right? This equation here is in general form. How do we like our equations of circles to be written? In that HK center radius form, right? So I don't like it in this form. I want it in center radius form. So we have to learn how to put it in center radius form. It's actually not very difficult. We're just going to use completing the square. But here's the trick. We have to use completing the square twice. Because how many variables do we have? 2. I have x and I have y. Okay, so we're going to use completing the square to put this into center radius form. All right, so let's take a look at this. Somebody want to read that off to me again? Okay. Now, I want you to notice a couple of things. Notice right now the x's are grouped together and the y's are grouped together, right? If they weren't, you would have to rearrange this to make sure that the x's were together and the y's were together. You okay with that? I also want you to notice that it's already equal to the constant. The constant isn't over on the left-hand side of the equation, so since it's already equal to it, we don't have to do that extra step of bringing it over, okay? So here's what you're going to do. When you set this up, you're going to rewrite it, but you're going to leave a little space, because what do we find when we complete the square? What do we find when we complete the square? What's the point of leaving a space here? We find the new c term, okay? So you're going to leave a little space so that you can put that C term in. All right. How do I find the C term? B over 2 squared. Good. So we have to do it twice. We have to do it for the x, and we have to do it for the y. Okay? So for the x, we get 6 over 2 squared, which is 9. So we're going to add it here, and we're going to add it here. All right? What you do to one side, you have to do the other, 6 over 2. It's your b. So if you add it to one side of the equation, you have to add it to the other. Okay? Now we're going to do it for the y's. What's my b? Over 2 squared, which is? Good. So we're going to add here and here. We doing okay? All right, so once I have my new c term in, what was the next step in completing the square? Good, we got a factor them. X squared minus 6x plus 9? X minus 3 squared. Okay, it would be x minus 3, x minus 3. X minus 3 quantity squared. Plus y plus 5 squared, and that equals 100. Now, is that in the right form? Yeah, sure. X minus h quantity squared plus y minus k quantity squared equals r squared, right? So what's the center? 3, negative 5. Excellent. What's the radius? Great. Okay. So that's how we go from general form to center radius form, by completing the square twice. This was on the Regents exam last year, I believe, for 4 points. Okay? So you have to know how to do it. No, it's not bad. You just have to remember, group your x's, group your y's, and then complete the square twice. Okay? How do you feel about that? Okay, so what you're going to see on the next few pages is you're going to see a whole bunch of circles. Okay? What your job is to take those circles and come up with the equations in center radius form. Okay? So if we look at the next page, there's 2 ways you can do this. You can sketch this in your notebook and label them in there, or you can open a text box. You guys know how to open a text box? Menu, actions, text. Okay? Menu, actions, text. You can open a text box and make up the equation. All right? So if I look at this small circle here, all right, this one here, in order to come up with the equation, all I need is the center, and I need the radius. Okay? So my center is 2, 3, and my radius, I can count this one out, is 1. So my equation, x minus 2 quantity squared plus y minus 3 quantity squared equals 1 squared, which is 1. So what you're going to do is you're going to go through and you're going to label all the equations of these circles. Okay? They should be pretty easy to find. Now, if you get to a radius that you can't count out, what are you going to use? The distance formula. Very good. You're going to find the equation of your, or the coordinate of your center. You're going to find a coordinate on the circle, and you're going to use distance formula to determine the radius. You're just finding the equations for these. Yep. Okay, so you're going to spend the rest of the class doing this. You got about 10 minutes. There's a whole bunch of these to go through. Okie dokie. So go ahead and practice. It's in your calculator, yeah.